Hey everyone, it's Tim here again, and we are setting up a Sokol environment, and we've just set up our shader. So we've just compiled our shader right here. Um, Now you'll notice that I've actually renamed the shader wrong there, so this actually should be glsl.h. Okay, so yeah, we've set up our shader. So this is our compiled shader we've got here, and this is a function here that we can call to get the description of the shader, and yeah. We're going to include that into our main file. So the last command that we ran was this one. So just to make this a little bit easier, we're going to include this into our make file. Okay. So down here, we're going to create a shader. Okay. And um, that's not what we want. That's still not what we want. Sorry. All right. Sorry. I'm just trying to copy this here and we'll just paste that there. There we go. Okay. So the dependency for this is what we actually want to generate is actually what we want the output file to be shader glsl.h. So this should be glsl, and we want this to be the dependency. Okay. And this is source. There we go. And what we can do is make a phony target here. So we might just create a dot phony. Phony target is when you're actually we're not actually generating a file. Okay, so we just say the phony target. I think this will work. Source shader GSL H. Now we should be able to just go make shader. Okay, that didn't work. Oh, nothing to be done. Yeah, that's correct. Make dash B shader. There we go. Yeah. So now if I edit this file, save it, and just hit make shader, it will regenerate that file. Okay, beautiful. Okay, now in our main file, we can include that file. Okay, so we can just include that header file, which is shader glsl.h. Okay, and when we compile our main file, any changes to that header to that shader file, we want to recompile our program. Okay, make. Okay, beautiful. So that's now including the source for that our shader into our main program, right? So now we've got to set up a bit of stuff here. So what we need to do first, so what we're going to do is follow this example, right? So you can see here in the init, we've got our setup function. We're going to have this vertex, right? So we might just copy this vertex because I think that's going to be very important. So this is, so what we're trying to do, we're trying to generate this triangle, right? So we've got sort of, basically there's three vertexes, one here, one there, and each one is a color. So this is red, this is blue, this is green, and then the shader will actually, as it renders, it will interpolate between all those different colors. So you can see here the positions. So um, we sort of have this set up like, I don't know if I can kind of draw it. This could be risky trying to draw this as part of this video, but you sort of have this grid set up where this middle point is 0, 0, And as we go across this direction, we're 1, and this is on the x-axis, and this is -1. And then up the top here, we have 1 up the top, and down the bottom there, we also have -1. Okay, so we've sort of got this little grid. If you could imagine this as a grid. Okay, and this is sort of the y-axis going this way, and this is the x-axis going, horizontally. So anything in this area be +1, over here will be negative on the x and positive on the y. This is negative on the x and the y, and this is positive on the x and negative on the y. Okay, so that is our little grid setup that we have when we're drawing. Okay, and you can see here, so we've got these positions. So this is 0, 0, so this is right in the middle. Sorry, this is a 2D. Yes, right. Sorry, this is a 2D plane. So the first position is 0, 0, and the next one is FF. So 0, 0, meaning 0 on the x-axis, and it's about halfway on the y-axis. So this is this first point here. So this is the first 2 dimensions. The third dimension is depth. And because we're on a 2-dimensional plane in this example, we can draw in 3D if we want to, but we're just drawing a 2D shape. So they're all got the same. This is the z-axis, right? How much depth it's got. And for the purpose of the example, it doesn't really matter. This could be all 0, but the example's got it as half. I'm not sure why it's got it as half, but yeah. And then the color. So the color here is red. So red, green, and blue. And then this is the alpha color. So you can see it's all fully transparent. And this is this second point is blue, and then this point is green. Okay, so there are our vertexes. Okay, so there are our points that we're going to deal with. All right, so first thing what we need to do with these vertex, we need to put it into a buffer. Okay, so I'm just going to sort of follow along here, but we set up a bind, and we've got a vertex buffer. Okay, and we're just going to set it in the very first element, and there's a function in Sokol called make buffer. So we're going to make a buffer, and we can just pass it the buffer description as the argument. Okay, and the buffer description just looks like that. So okay, and what we do is now set the data of the buffer. We use this SG range, and we just pass it the vertex. Okay, and the label can be anything, but we'll just call it, as per the example, triangle vertices. They should be commas, not semicolons. Okay, there we go. So we've set up our buffer. Okay, this is our bind buffer. Now we've set up our buffer, we need to now set up our shader. So we can create an SG shader, and we'll call it our shader, and all the so-called functions that start with SG, and then basically when you want to make a resource, there's a make, and so you can make buffer, shader, attachment. So obviously here we want to make a shader, and you can see there it takes a shader description. So we will pass in a shader description. Okay, and once again we will set that up. Okay, so for the shader description, actually, yeah. So the shader description, what we can actually do is, so instead of passing, so we could actually, sort of fill this structure out ourselves. So there's all this sort of data here, the vertex functions, the fragment functions, compute functions, right? So all that stuff, but that's already done for us as part of our generated shader code, right? So if we go across to our generated shader code, you can see this function called shader description, and you pass it in a backend, will actually, depending on the backend, will sort of set all those values for us automatically. So we've got, we've got a GL core backend, we've got a D11 backend, and we've got a metal backend, right? So we've got the 3 backends, and all that data is already set for us. So we don't have to set all that up manually. We can just pass that in by just calling that function, because we're including that file. So let's include that function. I forgot what it's called now. yeah, so this is shader description, right? So we can include the shader description as a function. Now the shader description takes a backend. Now we can get the backend by using a function in the SG library called query backend, and that will actually determine the backend for us. So we could use the compile flags, which sort of set it when we set it, but we can just query the backend. We can get the backend, and that will give us the appropriate shader. Okay, now we've got the shader. We actually need to set up our pipeline. So we will also do that. So we'll set our pipeline. Now we have a state variable that we were going to set the pipeline. So we're going to go sg make, and we'll make a pipeline. Okay, and once again, this takes a pipeline description. So this is a common pattern in Sokol where we just make a resource and we pass it a description. So we pass it a pipeline description. Now you can obviously use this as a variable, right? You can create that as a variable, but we're using yeah, a C99, I believe, feature, which is called, I forgot what they're called actually. I'll think of it later. Struct literals, I believe is what they're called. So we're using these struct literals. But I haven't quite done this right. What have I missed? Ah, that bracket there shouldn't be there. Oh no, sorry. So this should be a bracket around here like this. That's better. So struct literal. So it's instead of sort of declaring a struct here, so we could sort of declare a struct like SG pipeline description and just call it description, sort of declare the variable there and then pass a reference to that description in here. Right, so we could sort of do something like this, right? So we can sort of declare the description and then pass it in. We're doing a struct literal where we basically just embed that struct directly in the arguments of the function. Okay, so we don't even need that. So then the arguments of this description, we can have a look at this again. And you can see here, we get in the pipeline, we can set shaders, we can set the layout, and we can set some other stuff. But yeah, we want to set the shader. So we have a shader and we're just going to set it to this shader we created above, SDH, okay. SHD, sorry, is what we called it. And yeah, now the next bit is a little bit tricky. So yeah, if you're wondering how I'm doing this, I'm just kind of following along on this example right here. So we're set up our pipeline and we've set up our shader, and now we just need to set this layout. Okay, so the layout is basically the way this data here is structured. This is our vertex buffer, right? We need to tell the 3D renderer how our data is laid out. Okay, so I know this is laid out like this because I've got all these comments are here, but you know the program doesn't know that, like how many floats are or what type of data this is. Are these floats like? So we just need to describe this layout, right? So the way we do that is just say layout, and we're going to describe our layout. Okay. And in our layout, you can have a look at what our vertex layout state is. So we've got a layout state buffer and a layout state attributes, okay? So the layout, we have attributes, okay? And so we just set our attributes of our layout. Uh, yeah, attributes equal this, sorry. Okay. So this attributes is an array. So we're going to say what are our attributes. So we're going to say the first attribute. So this is an array. So we're basically saying the first one, the format is, and this is sort of saying what is the format of this position vector. Okay. But when we compiled our program, if we go to our shader program that we compiled here, up the top here, I believe we defined these attributes. Where is it? Yeah, here. So this define attribute shader pos. So this variable, this position variable, is defined as position 0. Okay, so the shader program actually defines where that position is, because that's going to be sort of how the shader and our program communicate, right? So they're saying this is in position 0, right? And this is what this layout 0, I believe this is what this location 0 is there in the shader program that's generated. So to make sure that we get the right position, because if you've got lots of variables coming in, you're just going to make sure that they all sort of match up. So if we go back to our main program, so instead of saying 0 here, we can actually just say the attribute shader position. Okay, so that is that there. And the format of that position is just SG Vertex format. Okay, and we've got a float and 3. So this is saying it's 3 floats. Okay, so as you can see here, our position is 3 floats. Now, there is a bit of a mismatch with our shader and our colors that I've just realized. So our shader doesn't actually take a color. Our vertex shader doesn't take a color, it just takes a position. So we might adjust that, but for now, I think what we're going to do is actually just adjust this shader. No, sorry, adjust our vertex to not include these colors. Okay, so I'm just going to remove these colors, and then in another video, we'll add the colors back. Okay, so at the moment, I'm just passing in positions. So that's it. So you can see here, I'm just passing in positions, and the format is float 3, meaning 3 floats, right? So each position is 3 floats. We pass that to our shader, and we can also set a label. So we just set a label. I actually don't even know what the label does, but let's just be good citizens and set our label. Okay, right now that's all looking good. Okay, so we've set up everything there. We've set up our pipeline. Now the last thing is when we draw our frame, we've got to actually apply this pipeline. So we've set up a pipeline. This is in a global variable called here pipeline. With our vertexes are in our bindings, okay, and we've got our action. So now in our frame, so every frame we're going to begin our pass actions, which clears the color. Now we need to apply our pipeline. So we can apply pipeline, right? And we're just going to use our global state and use our pipeline there. Okay. And we also need to apply our bindings. And we'll also use our state. And the difference here, this one takes a pointer. So when we go to bindings, you can see there that takes a pointer to bindings. The pipeline is not a pointer, it's just actually an ID, right? So when we make it, it just returns an integer ID, whereas the bindings is actually a pointer. So we're just going to make sure that we do that. We end the pass, and then the last step is to draw the thing. So let's call SG draw. So this should draw everything in our pipeline, 0, 3, and 1. Now I believe those arguments are the base element, which is I think where we're starting, but I might be wrong on this, but this is starting at 0, meaning draw the first vertex. Number of elements, we've got 3 vertexes, and number of instances 1. I don't even know, I'm actually not sure what that is, but we'll figure it out as we go. So I think that's it. So let's run it and see what happens. Let's make run. And look at that, we have a red triangle. So how about that? That is awesome. So we've drawn our triangle. You can see there, this is our position. Now, if you wonder why it's red and not the colorful one that we're trying to get, that is because we are not passing through any colors. We're just passing through positions. And in our vertex shader, we are setting the color to red. But if I change this to blue and run it, we don't get a blue, we get a green one because it goes red, green. So this is green, not blue. And if I go like this one should give me a blue one. There we go, there's blue. So, you know, we can sort of get any color we want now. So we can get a black one. And if we want white, we'll go 1 for white, 1 all the way through. Look at that. And if we do a red, but we give a little bit of transparency, so this is the alpha color, we should have a little bit of a light red color. There we go. So there's no transparency. I don't know why that's not working, but potentially it's something we've got to set to get transparency there. But yeah, anyway, that's very interesting actually. Anyway, yeah, in the next video we'll have a muck around with some. We'll get these colors and we'll get the colors working in the shader. All right, I'll see you next time.